Transition metals have wonderful properties that they are all related to their electron configurations. They have variable oxidation states, form complex ions, they form colored complexes, have magnetic properties and catalytic properties. To look at their properties, let's just dissect their electron configuration and look at the variable oxidation state. But first, the definition. In order for a metal to be known as transition metal, it should have at least one oxidation state with partially filled d orbital. So if you look at period 4, which is the only one that you should consider, zinc is the only one that is not a transition metal, and it's known as d block element. Zinc only formed 2+, and by losing 4s, because D are completely filled, so it's not a transition metals. Then I also put chromium and copper in green, so you remember the anomalies. Those are the only two elements that have 4s1 rather than 4s2, because we have 5 d orbitals, and chromium prefers to have single electrons in each, and copper prefers to have paired up electrons in their d orbitals. So if you look at their oxidation state or charges, I put the most common one in bold. Scandium is not a typical transition metal, but it can form +2 and +3. So if these are your valence electrons, they are extremely close to each other. And first is you always lose +2. So all transition metals for you should remember they have +2. Then once we go from scandium to manganese, you see the transition states increases. Manganese actually has the most, and then there's a decline, you come down, and copper is the only one that shows also +1. So these are a few things that you should remember. Therefore, all transition metals can form +2, and also you can lose one by one of the d electrons and form variable oxidation states. So there are a few notes here that I have highlighted. It's worthwhile to remember, and you should be able to do electron configuration of transition metals as well as to appreciate their variable oxidation states.